Hey guys, now in this video we will be moving towards the understanding of graphs. So, understanding of graph. We have seen that there are three kinds of graphs. First, we'll be talking about the displacement time graph. Time graph. For example, I have a graph here. We make a graph here, and just the scale can be a little annoying. Times it is annoying. Now, for example, this is a displacement time graph. On displacement time graph, on the y-axis, we've seen we have displacement, which is denoted by an AS. On the time graph, we have the time in seconds, while this would be in meters. As the SI unit of distance is displacement is meters, and for time it's seconds. Now let's see. Let's understand what a graph means. This is a line here. This is a line here. And then there's a straight line here. This is again a straight line here. Okay? Now, for example, this is our 0 and 0. Let's just understand the graph. What's happening here? For example, this is 6 on the graph, which means this is 6 meters. So what happens in the graph? In the first stage, for example, this is the stage A, this is the stage B, and this is the stage C. For example, if this is a car, always remember that a distance time graph will only tell you, by looking at it, by only the observation, it will only tell you about the distance. It will tell you a lot more things if you calculate them, but by looking at it, by observation only, you'll only be able to find out the distance. For example, this is the car, which is at here, at a point O. If I talk about the end of this point, by this time, let's say this is time 1. By this time, the car has reached a point, let's say point 1. Which is 6 meters, I'm saying this is this point, which is 6 meters away from 0. So, the car at t is equals to t1 at some time, random time, this car is now here, which is 6 meters. Let's see the second part. The distance remains the same throughout, although the time is changing. Time is increasing. Time is a never stopping quantity. So it's increasing, but the car is not changing the distance. It's not doing anything. The distance remains the same. Even this is 6 meters. You can see this is 6 meters again. This is 6 meters. Just assume this is a straight line. Don't be confused by the scale. So all of these points are in 6 meters, which show that the point, the car remains stationary during this time. It's just there. It's not moving. It's just standing there, standing still, with a 0 velocity. It doesn't have a velocity. It's just standing there. And then, during this point, from this point onwards, this point, let's say this is t3, the car comes in this time interval, the car comes from 6 meters to 0, back to the original point. This is the original point. So what happens is the car turns around, and during this time interval, it comes back right here at the same point again. Because the distance is now 0. The distance from the point O is now 0. It's back on point O again. The y coordinate of this point is 0. So this is some basic understanding of a displacement time graph. Remember, I cannot say anything about the speed. I don't know whether the speed is increasing or not. I'm only talking about the distance. The distance increased in this point and the car reached a point 6 meters. After that, the distance didn't increase since all the points were at the same level. After that, distance started decreasing. So it was coming closer to the original point. You can see that it's coming closer to the original point. The original point is this on the y-axis. It's coming closer to this point on the y-axis. It's decreasing, and so it comes to its original point at t is equals to 3 seconds, or t is equals to t3. So this is the displacement time graph. For now, it's not telling us about anything at all, just the distance. You should always remember, just look carefully what graph it's about, and you will be able to find out the distance only by looking at the graph. And this is a linear curve because it's made up of straight lines. This is a linear graph, as we saw earlier. Let's talk about velocity time graphs. So let's make the same graph again, and let's see if it's a velocity time graph, what information do we get from that. The information, you will see that it will be totally different from okay. So this is a line like this, this is a line like this, and this is like this, coming back here. All of these are straight lines. Just remember, I'm not using a scale for this because it's taking a lot of time here. So on this scale, we have, since it's a velocity time graph, we have v in meters per second and time in seconds. Okay, now let's see if this is 6. What does this tell you about the motion of a car starting from a point here, origin? This is the O point, which is this, the origin. Starting from here, what does it tell you about the car? At time t is equals to 1 seconds, for example, or t, at a random 1 seconds, I'm just taking this random value. The velocity of the car, the speed of the car has increased to 6 meters per second. That means that here the car was stationary because its velocity was 0. Now we are talking about the velocity. Always remember, we're not talking about distance here. Okay, we're talking about the velocity. It might as well be confusing right now, but just make sure you know what this quantity represents. So here it represents 0 meters per second at the beginning. At time t is equals to 0, this is 0 meters per second. Velocity of this car is 0 meters per second. However, at some time t is equals to 1, the car attains a velocity of 6 meters per second. Then, for example, this is time t is equals to 4 seconds. Till time t is equals to 4 seconds, the velocity of the car remains constant. It's constantly moving at the same velocity. The car, till time t is equals to 4 seconds, the car has the same velocity as it had, since all of these are at 6 meters per second. So the car is moving at the same velocity as it was moving earlier. And now, after this point, for example, time t is equals to 6, you can see the car is slowing down since the velocity is decreasing here. You can see the corresponding velocities will be decreasing. At this point, it's lesser than 6. For example, 4. This is 3 here. This is 1 here. And this would be 0. So it doesn't necessarily come back to its original point, but what happens is at time t is equals to 6, the car comes to a stop. this is a car, this is the car, and its velocity is 0 meters per second again, because on the y-axis we have 0 meters per second. We don't know about the distance right now. By the observation, we can only tell you about the velocity of the car at different points, because we have the velocity scale, and depending on the time we can tell you about the velocity. So if I tell you what is the velocity of the car at t is equals to 3 seconds, so all you can do is t is equals to 3, just take this line here and just find out. Velocity is 6 meters per second. So we know this, that from t is equals to 1 to t is equals to 4, it was moving at a constant velocity. The velocity did not change throughout. So always remember that with the velocity time graph, you will be talking about the velocity only, and not about the distance or any other quantity, only the velocity. Okay, so make sure you know about that. Now the third and the last one, the acceleration time graph. Let's take an example here. Now I'm drawing the same graph. This is the line here, and the line. Okay, so this is a straight line. Just imagine this is a straight line like this. Okay, just don't get confused with the incline. It is just a straight line like this. Okay. And I'm making it worse, but just imagine this is a straight line. Don't get confused. Okay, so this is 6. For an acceleration time graph, we will have the acceleration in the y-axis. The unit of acceleration we know is meters per second square. And on the x-axis, again, we have the time in seconds. Now, let's see what it means. This can be a little confusing. Let's see, we have a car here. See, we have a car here. And at time t is equals to 0. Sorry, yeah. This tells me that the acceleration of the car is 0 at this point. So I know that the car is not accelerating at time t is equals to 0. The car is not accelerating. But I do not know about the velocity. And we know that the acceleration can be 0 even if the car is moving at constant velocity. So this does not mean the car is at stop. There are two conditions for acceleration is equals to 0. One, it might be at a stop. The car might be at rest, or the car might have a constant velocity. So even for a constant velocity, the acceleration is 0. So I can tell that here initially the acceleration is 0, which means there is a constant velocity. It might be at rest or at constant velocity. I don't know. I would just say the acceleration is 0 here. So never assume that the velocity is 0, because it can be at a constant velocity as well for acceleration, and the acceleration would still be 0. So now at point, for example, time t is equals to 2 seconds. Time t is equals to 2 seconds. The car has changed its acceleration, and now its acceleration is 6 meters per second square. The car has increased its acceleration, and the acceleration at time t is equals to 2 seconds is 6 meters per second square. So always remember, this is an acceleration time graph. So this is not telling me about the velocity. The acceleration is 6 meters per second square. That means that it is moving whatever the velocity here it is. For example, the velocity can be different. Velocity can be, for example, 20 meters per second at this point. But it is accelerating. Its acceleration is 6 meters per second square, which means it will increase its speed by 6 meters per second every second. The next second, the speed would be, it's 20 right now. The next second, the speed would be 26. The next second the speed would be 32 plus 6 plus 6 plus 6. You will keep adding. That is what it means. Don't get confused whether the velocity is 6 or not. No, the velocity can be different. Acceleration simply means that whatever the velocity is, there will be an increase of 6 meters per second every second. So let's say till time t is equals to 5, the acceleration remains constant. It's 6 meters per second square. So throughout this distance, the car is increasing its velocity by 6 meters per second every second throughout this interval. This does not mean the car has a velocity of 6 meters per second. No. Always remember the graph is acceleration and time. So the acceleration is 6 meters per second square, which means the increase in velocity is 6 meters per second. 6 meters per second per second. That is why it's 6 meters per second square. Now, after this point, after t is equals to 5, the acceleration starts to decrease. For example, let's say this point, t is equals to 6. At this point, the acceleration, for example, is 5 meters per second square. T is equals to 5. At this point, for example. This does not mean, always remember, this does not mean that the velocity is t is equal to 5 meters per second. No. It means whatever the velocity was at this point, it will increase by an acceleration. It will increase by 5 meters per second every second at this point. So if the velocity is 20 here, if this acceleration remains constant throughout the journey, which it is not, it's just decreasing constantly. So, but if this means that if it remains constant, the next second the velocity would be plus 5, just 25. This is what acceleration means, that every second there will be an increase of 5 meters per second. In the next point, you can see the acceleration is decreasing. Here it might be 4, 3, 2, 1, and here again the acceleration is 0. This does not mean the car has come to a halt or it is moving at a constant velocity. We are not sure about this because there are two conditions for acceleration to be 0. But one of them might be true. It might have come to a stop, or it might be just simply moving with a constant velocity. So this is the understanding of all the three graphs that you should have before we move on. These are the observations that you can make simply by looking at a graph without any calculation. Just the observation. So always whenever you get a question, just try to understand what is happening in this situation so that you get a hang of it. After that, we'll be moving on to the next videos where we'll be talking about gradients. So stay tuned, guys. Thanks for watching.